this video, let's explore some of the FortiOS 7.0 wireless improvements. Network access control helps enterprises implement policies for controlling devices and user access to their networks. Existing techniques such as reduced dynamic VLAN, reduced MAC authentication, multi-purpose shared key VLAN assignment, or VLAN pooling, the new NAC feature is allowing to bind specific devices into a dedicated VLAN and therefore apply security policies. If we take a real case study where NAC is being needed, we would need in a school some different level of access in function of the device type. Students would have iPad, staff would have Android devices, and the rest would stay unclassified. The integrated FortiGate NAC was already providing NAC function to the FortiSwitch networks by using a shared set of NAC policy. Part of 7.0 changes, it is now expanded to also cover wireless. To note that this feature is using in the backend the powerful FortiOS device detection database. It can also be used in conjunction of the FortiGuard IoT service that is transforming any access point or FortiSwitch into an active detecting device. How this NAC can be configured. Any already defined SSID can be transformed into a NAC controlled one in few clicks. The 7.0 wireless NAC is using the onboarding VLAN to detect, classify, and allocate VLAN to stations. There is no defined NAC policy for the device type. Stations would stay in the onboarding VLAN. By configuring the first SSID VLAN, that would be the onboarding one. DHCP and device station have to be configured. As it can be seen, we specify the VLAN ID 4089 to this new SSID subinterface. Now configure two other subinterfaces. One will be the student VLAN that would be on VLAN ID 4. As you can see, the parent interface, similar to what has been done for the onboarding one, is the IoT NAC SSID. We will add the staff subinterface on VLAN ID 3 with its corresponding DHCP server configuration. Now check, all three interfaces are underneath the parent SSID. Now enable NAC on the SSID itself. We enable the NAC profile and then create a new one. We would specify the onboarding VLAN and apply the settings to enable NAC feature on the wireless SSID. And final task is to create some NAC policies to allocate VLAN to wireless devices. The first one is the student's SSID where iPads would connect. The device pattern can take different elements such as MAC address, hardware vendor, device family, device OS, or user. The Fortinet user group can also be used. As part of the entered string, we do support wildcard to ease the detection. Then, as action, we would define the VLAN where stations would be bound to. We will finally create the staff access NAC policy to bind Android devices to VLAN ID 3. Let's connect some devices and see how this new NAC feature is behaving. By looking at the connected Wi-Fi clients, we can clearly see that no station is currently being connected to the IoT NAC SSID. We'll start with a Wi-Fi 6 Windows laptop. Once connected, we can clearly see the IP address is obtained from the onboarding VLAN. Additionally, we can see the allocated VLAN from the VLAN ID column. As we did not create any NAC policy for Windows laptop, this station would stay in this VLAN. We'll then connect one student iPad followed by two Android devices. Again, the station would start with the onboarding VLAN, and once analyzed by the device detection engine, would be categorized and allocated to their corresponding VLAN. In order to ensure network connectivity, as DHCP scope is different in each VLAN, the stations would be disconnected from the SSID, wnac.lan for staff, and wnac.students for students. Once reconnected, they would be placed in their corresponding VLAN. We have seen how simple it is to associate a VLAN to a type of devices. FortiOS 7.0 is also adding the capability to enforce DHCP on the configured SSIDs. Station with a static IP would be disconnected and not able to process traffic. As we can see here, the station is trying in loop to connect and is being rejected. This feature can be enabled on top of any existing SSID, including the ones with built-in NAC enabled. Another area that FortiOS 7.0 is improving is wireless monitoring. In previous release, we introduced wireless station drill down, allowing to get in-depth station details such as performance, bandwidth, SNR, discard and retry rates, as well as application, traffic destination, match policies, and station logs. View can be bubble or table view. FortiOS 7.0 is expanding the already existing FortiAP drill down to add useful performance charts as well as AP position in a map. The performance section will give a per radio live troubleshooting data such as amount of clients, TX and RX bandwidth, as well as channel utilization. Some really useful tool when troubleshooting on-site wireless issues. The Wi-Fi map is the same as the overall FortiOS map feature, but is highlighting AP position on top of client count, operating channel, TX power, and channel utilization.